Engineering Mechanistatic Lecture 10. This is the last part of subject moment, which is moment of couple. These are the objectives. Student will be able to define a couple and determine the moment of a couple. This is one of those of the example of the couple moment. So it will have a couple of moment acting in the opposite direction. So this one is of course in the right direction, and another one is in the left direction. So this system we call it as a couple of moment. So first let's define what is a couple of moment. Okay, the couple is defined as two parallel forces with the two same magnitude but opposite in a direction, separated by a perpendicular distance d. So there are 2 points which is important to define what is a couple. So it must be has two parallel force, and then the magnitude of the force must be the same, but the direction of the force must be opposite. One to the right, one to the left, and another one to the right. Okay. So and then the force is separated with the distance d here, and it will the rotation of the couple force will produce a moment, okay, in this direction. So you can use the right hand rule to determine the direction of moment. So your finger here will be rolled with the same direction of the rotation, and then your thumbs will point out the direction of moment. So to find the moment is simply, if there's two methods. If you are using the scalar analysis, so simply m0 is equal to f, the force, multiplied with the distance d. Okay, or d is also a line of action or vector position. And then if you are using the vector analysis, so the moment you can use the method of cross product between r and force. So r is a line of action or position vector. Okay, so here r is any position vector from the line of action of negative f to the line of action of f. So the r is the same is the same length with d actually, which is from this line of negative f to this line of f. So there are a few important things that you need to remember about the couple of moments. So the first one is couple of force. So the net force of the couple force is equal to 0. Okay, so the net force of the couple force is equal to 0, because when you sum up the force in the right direction with the force in the left direction, which is negative, so f minus f, this is equal to 0. Okay. And then for a couple of moment, to calculate the moment of a couple force system, okay, so using the right hand rule, so your moment will be is equal to this length of d multiplied with point of the force, either this one or this one. So d multiplied with f, force, and then the D, which is a length from negative F to this F. Or simply, if you want to calculate, or frankly speaking, if we want to calculate the moment, the couple moment, so we need to take out this part. So simply multiply D with F. Okay, let's do some example here. Given a force couple acting on the rod, okay, you have a rod like this, so you have a couple of force. One force is in this direction, and the other force is in the opposite direction of this force. And then find the couple moment acting on the rod in Cartesian vector notation. So you want to find the moment of this couple force system. Okay. So because this is a three-dimensional cases, and the question asks you to find the moment in a Cartesian vector notation, so you must use the solution of operational cross product. Okay, because cross product will produce the answer in a vector Cartesian form. Okay, so use M equal to R cross F, and then set R is equal to RAB. So please remember, when you want to find the moment of the couple force like this, so your moment must be from negative F to F, so from here to here. So this is your line of action of R, and then this is your F. Either you take this F or this F. So in this case, I take this F here. So R cross with F, so you will get the moment of this system. Okay, and then calculate the cross product to find the M. Okay, so first, how to find the RAB? So find the coordinate of A, the coordinate for A here. Okay, so let's say I write here, this is the coordinate for A. What is the coordinate for X, Y, and Z for A? Okay, coordinate for A, for X is 0. Okay, because this is the point of origin, and then the Y also 0, and then for Z is 0.5. Okay. The point A is here. Okay, so don't confuse with that. So this is point A, and then the coordinate B. Okay, your X is how much? From 0 to here. Okay, this is your point B. So from here to here is 0.8. Okay, so 0.8. Okay, I'm using mouse, so it's difficult to write. Okay, your Y is 1.5. So your Y is from here to here. Okay, so it is made up here, so it is 1.5. And then from here it is made up in a point B here for the z-axis. For the z from 0 is 0.5. 0.5. Okay. And then to find the RAB, so remember how to find the position vector. You must subtract, this is the tip, okay, because it is from point A to B. Okay, so this is the tip and this is your tail, so subtract tip with tail. So each component subtract their respective component. I subtract the I, J with J, K with K. So 0.8 minus 0 is 0.8, and then 1.5 minus 0, 1.5. So 0.5 for point B minus 0.5 for A. So I'm missing one thing. This is actually negative. So because it is downward from the 0 axis here, so this is negative. So negative minus 0.5 is equal to 0.1. Negative 1, sorry. Okay, so this is your RAB in a Cartesian vector form. So your F is already given here. So just do the cross product operation to find the M. So as usual, do this matrix. The first line is for your vector Cartesian for R, and the second line is for F. And then do the cross product operation if you want to find the I component. Okay, eliminate this line and do the cross product operation for this one. Okay, so I clear up all the lines here to make it more clear. So when you do the cross product for component I, just eliminate this line and then do the cross operational for this one. Okay, so 1.5 multiply with negative 6, you will get negative 9. Negative 8 multiply with negative 1, so you get 8. Okay, so minus. So please remember the formula how to do the cross product operation. Okay, and then J, eliminate this one. Okay, so do the cross product between the one that is not being eliminated. Okay, so you'll get this one. Okay, also do the same thing for K component and you will get the answer in the vector form. It's like this. Okay, so this is your moment for your couple moment system in a form of vector Cartesian notation. Okay, that's it.